Hello everyone, I will be showing my reinforcement learning project for the CDS524 course. In this project, I've implemented a snake game that uses Q-learning to train an agent to play the game. So I will demonstrate my game first and explain my Q-learning implementation. So let me start by showing the game. As you can see, I will run my code. It has a menu, so the users can choose two different models. One is AI training mode, and the other is human play mode. And first, let me see the human play mode. As we can see, the human play mode, the player can control the snake, use the arrow keys. The objective is to collect as many red food to for the snake to eat. Each time snake eat the food, it will be longer, and the player has to avoid it hit the wall and itself. And we can see the score and the game run in the top of the window. And we can press the ESC key to exit the game. Now let me change to the AI mode. In this mode, the snake is controlled by Q-learning algorithm that learns to play the game through trial and error. In the beginning, the snake makes some random movements, as you can see in the window, and it often hits the wall. So we have to train it. Now, as training progresses, we can notice it starts to make more intelligent decisions, learning to avoid walls and its tail while seeking food. And we can see the game run and score, the highest score record epsilon in the window. Now let me end the game. So now let me introduce the code structure of this project. This game uses Pine for the graphic and user interface, and PyTorch for implementing the Q-learning network. So as we can see, the button class manages the interactive buttons, including their rendering and click detection. And the menu class creates the initial interface where users can select between AI and human modes. Now let's see the core of our game, the snake class. So it contains some important method. The reset method is used to initialize or reset the game state. It can place the snake and foot in their starting position. The place foot method is used to randomly position new foot on the grid, ensuring it doesn't overlap with the snake. The place step method is used to handle one step of gameplay, including movement and reward calculation. The collision method is used to check if the snake has collided with walls or itself. The update UI is used to update the current game state to the screen. Move method is used to translate action inputs into directional movement. The get state method is used to convert the game situation into a state representation for the Q-learning algorithm. And for the reinforcement learning implementation, we have the DQN class to define our neural network architecture. It has a forward method that process input through the network and a safe method to store trade models. The agent class is used to manage the learning process. The get state method obtains the current game state. The remember method is store experience in the replay memory. The tree long memory is learning from batches of past experience. And the tree short memory is used to update the model based on single experience. The get action method is used epsilon greedy police to select action. So we also have two main gameplay functions. The train function runs the game in AI training mode and handle the learning loop. The play human method runs the game in human controlled mode and take keyboard input. That's the code. Now let me talk about the Q-learning algorithm. Q-learning is a form of reinforcement learning where an agent learns to make decisions by receiving rewards or penalties. In traditional Q-learning, we use a Q table to store values for state action pairs. In my snake game, I use a neural network to approximate the Q function, an approach known as deep learning. So in my code, I calculate the target Q value based on the reward and the maximum Q value of the next state. As you can see, and we use an epsilon greedy state G. At the beginning, the agent mostly take random actions. So if we can see the high epsilon, allowing it explore the environment. As training progresses, the epsilon will decrease, as we can see, because the agent starts to rely more on its learned Q value, explore the environment, what it has learned. So this balance is very important for learning effectively. And I also ran into some problem in my development process. For example, in the beginning, I found that the AI training speed is too slow, so so it has to take too much time to see the training result. So in order to solve this problem, I crank it up, but I found that human couldn't play the game normally. So in order to solve it, I set two different speed for each mode, so the AI will train it faster, and the human can play in a normal speed. And another challenge is that it's difficult to decide effective state representations. So let me see. So I only decide three most relevant information to optimize the danger detection in three directions, and current movement direction, and relative foot position, as we can see. So this compact representation helps the agent learn more efficiently. That's my introduction of this project. Thank you.